Hello everyone, in this video I want to show a image processing workflow that I remade in Houdini. So for a video game I was developing previously, I had the need of combining those three different images into a single image, so that in the game I can just load a single image and use its RGBA channel respectively for friction, height, object map, and mask. So if you take a look at the height map, this is referring to a golf course somewhere here in Toronto. So you can see the darker value represents the valleys, the higher value represents trees and the tall buildings. And the image itself has a size of about 4K, 8K times 5080. And we have a friction that represents friction of different ground types. In general, brighter value represents bigger frictions. It doesn't really matter the value range. And then we have the mask that represents playable area versus non-playable area. And lastly, we also have the object map that different grayscale value represent different terrain type. For instance, this represents a tree. This represents I don't quite remember. This one represents the cart path. The white one represents invalid area, right? So that is the four images. During the image creation process, I will manually paint those ones, but eventually for publishing with the game, I want to combine everything together into a single image. Now, when you view this image in Windows, image viewer, it will automatically hide the rest of stuff, but when we actually read it in the game, we are not multiplying the alpha, because alpha channel has its unique meaning, which is a mask. So previously, in order to achieve this, I have to write a program, and it's a very simple program, but still it's a program, and it required skill sharp, and I used C#.NET 8. The most important function here is combine channels. For all the images we have, I'm reading only the red channel. So for all the four layers, we only need a single grayscale channel. In this case, I'm just taking the red channel, and I'm converting those ones respectively into corresponding red, green, blue, and alpha channel, right? If we look at the code site, you can see that for all the images we read, we are just loading the bitmap, and then here there should be a place where we only read a single channel. Actually, we read the entire bitmap, and then from there we are combining the channels. Yeah, so actually, so it's shown here. So for all the channels, for all the layers, we are getting only the red channel. And then in this particular function, we are just trying to combine all of those bytes together by using a bitwise manipulation. And there are complications here because of the way ScaleSharp works. It always tries to pre-multiply the alpha. So if we just do a naive fetch the pixel value and then use a SK color and put in this alpha value, which may be anything between 0 and 1, then when we set the pixel, this color, despite we explicitly set the alpha, it will pre-multiply the alpha. So the RGB value will actually be multiplied by A before being written to the pixel. So we have to use an unsafe block to manipulate raw bytes, do a bitwise operation to create this final 4-byte sequence, and then save it to the corresponding pixel location. So this one works, and it's a little bit slow because it's CPU bound, and we didn't do any parallelism. There's no multi-threading logic. I can improve that, but it's it kind of works, but not very convenient. On the other hand, if you go to Houdini, here I have a network setup. Here we are inside a Copernicus. We are using Copernicus, and we have 4 file loads that reads in the corresponding files: the friction, the height, the object channel, and we can view each one of it. So this is actually 8K, 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 right? And then we do a channel split, and we only extract the red channel from all of the images. And you can see we only extract one channel from all of the images. And then we do a channel join, which will combine all the 4 channels together, produce the final resolution, and we are pretty much done here. But because I'm using Apprentice, there is a output limit, so if I just try to drag it over here and do a run to disk, it's going to give me an error because Apprentice cannot output anything bigger than 1080. So what I'm going to do here, for the purpose of demonstration of course, I'm just going to do a resample, change the scale to a much smaller size, in this case 2029 times 762, and then render it to the disk. And now with pretty much, this, if you are familiar with Copernicus, then it's like a few seconds setup, right? And then you have the final output. The output, looks the same compared to the the higher resolution one that we wrote in C#. Although there's a logo here, so you cannot really use this one, but you get the idea. So that's very cool. I just want to share this updated workflow. Practically I would probably not use this because the problem with this one is I have to save it as a Houdini file, and then every time I want to run this, I need to open Houdini. Although if you use Python, or specifically if you use Python, then you can run a file in a headless mode, so you don't need to open Houdini. But still, could be a little bit inconvenient because the user need to install the program, right? On the other hand, if we have a C# program, I can just publish it, and in this case, it's going to be a single binary executable. In this case, that's pretty much it, and then people can just run this one. So there's a trade-off. But I think for development purpose, for if it's an in-house process, then I think it will make sense too, because this one is much simpler and much easier to customize, and actually it's so fast because everything runs on the GPU. So that's it. That is how you can combine 4 different images into a single image in Houdini. Thank you for watching.